Part 2 of lesson 32 deals with centripetal force, and once again we're going to derive some formulas. We're going to derive a very important formula that is not on your formula sheet based on this formula here, F equals ma, but we've put a subscript c there, which means centripetal. So the centripetal force equals the mass times the centripetal acceleration. I'm going to take that formula there. Now we're going to do this in two. We'll split this. So split in two, we're going to derive two formulas from this. So we're going to start with two formulas that we know. One is FC equals MAC. So that formula we know. And we also know that AC equals V squared over R. So this is a fairly straightforward derivation and a very important one. We can see that if we take this value here and put it in here, we get a new formula, and that formula is FC equals MV squared over R. This is not on your formula sheet, not on it's not on your formula sheet. It's one you should memorize. You'll use it a great deal in physics 20, and you will also use it in physics 30. The centripetal force equals the mass times the velocity squared divided by the radius. The other formula that we can derive from this one, not as important, but could save a lot of time in some questions, is so this formula here is one we derived in the last lesson. And we can do the same thing. We can just take this whole thing and substitute it in here. Giving us this formula, which people commonly write as 4 pi squared mr over t squared. So, and subscript c. So there's another formula we can use for centripetal force. I wouldn't worry too much about this one. It will make some questions easier, but you can always just use this one and get it that, and just use two steps instead of using one formula with one step. Okay, so let's have a look how this applies. We have, oh, there's a good video. Oh, there's a great video on the centrifuge. You'll have to go and watch that. So here's a centrifuge. Centrifuge goes round and round and round, makes you really dizzy, makes you throw up. It tests G forces. So if you get something to be an astronaut or a fighter pilot, you have to be able to withstand a certain amount of G forces, and they stick you in a centrifuge and see how well you do. So here's a centrifuge going around in a circle. It says determine the centripetal force acting on a 100-kilogram person to be spun around in an 8.8 meter circle at 10 meters per second. Okay, and we're just going to assume that 8.8 is the radius, right? The centrifuge is unlikely it would be only like 10 meters across the whole thing. Probably from here to here is 8 meters. So let's assume that that's the radius. Question A, radius is 8.8 meters. The velocity is 10.0 meters per second. And we're asked to find the centripetal force. And this is easy because we just derived the formula. Oh, and I forgot to write mass. Mass is 100 kilograms. Now, what that ends up giving you is an answer of 1.14 times 10 to the 3 newtons. So 1,140 newtons, let's say, which is, it's not a huge amount of force. but it's a little more than if you were just standing still. So if you calculate that into G's, the way that we change things into G's is we divide them by 981, or you divide it by 9.81 times the the mass of the person. So if I take that and just divide it by 981, I get this. And you don't really need to know G's. It's more for your own interest. 1.16 G's. Remember that everybody just standing on Earth is experiencing 1 G of force. So if you're going in a centrifuge at that velocity, you can experience 1.16. That's not going to be terrible stressful for you. But if you just increase the velocity by 5 meters per second and do the same calculation, so it's going to be exactly the same, except now this is 15. All of a sudden, this works out to be 2.56 times 10 to the 3 newtons. Again, divide that by 981, 100 times 100 kilograms times 9.81 meters per second squared, and you get 2.6 Gs. 2.6 Gs. Should be no apostrophe there. So just by increasing the velocity by 5 meters per second, you didn't even double it, you more than double the G's. Right? So you can tell, I mean, if I double this, if I put a 30 in there, oh boy, you're going to feel that. Oh no, there's another example. Continuing on, the last example is determine the centripetal force acting on 100 kilogram mass in an 8.8 meter centrifuge if he is spinning at 15 RPMs, or 15 revolutions per minute. So we want to find the centripetal force. We have the mass, we have the radius, and what do we have here? 15 RPMs. It's just a unit of a frequency or a period. So let's convert it to one of those. What do we want to get? Well, we probably want to get the period. The period would be nice to know, right? Because in that case, we can go to the formula, the second formula which we derived, and plugged it right in. We'll do the long way first, and then we'll do it the short way. So let's do it this way. We need the period, because then we can plug it into this formula here to calculate the centripetal acceleration, and then this formula here to calculate the centripetal force. So first of all, we get the 15 revolutions, 15 cycles, revolutions per minute. So 15 cycles per 60 seconds equals how long for one cycle? Right, so if you do that, cross multiply by, it looks as though you're going to get 4. So it takes 4 seconds to go. If it goes around 15 times in a minute, it goes around. It takes 4 seconds to go around once. And now we can just plug that into this formula here. 4 pi squared r t squared. Oh, that should be 4 squared is 16. That's going to give you an answer of 21.71. And then take that answer and there's your answer. In correct significant digits, that's going to have to be 2.2 times 10 to the 3 newtons. And if you did want to use the other formula that we derived, over here, then that formula is going to be the 4 pi squared mr over t squared. And as you can see, by using that formula, we have m, we have r, we have t. So it's just one formula. It's just this step here to find out the period, and then into one formula. You're going to get the same answer. But in all honesty, I would probably just do the two-step method. It saves you from having to memorize this formula here. Or memorize how to derive it. But once again, I can't reiterate enough, the experience or the practice of deriving formulas, making new formulas is a very important part of physics and science in general. We'll see you for lesson 33.